Hi, everyone. Thanks for coming back again. Today we're going to do Ken Shoulders number 23 from the information that Chris Beskar gave me on his. Chris he was in a business relationship with Ken Shoulders to use some of the charge cluster technology that he had. But today I have something kind of interesting that this is something that Chris did send me. Um, it is from Ken Shoulders. You can see that his phone number is at the bottom there, and he's just talking about a very cool flying machine. This is something I've always wanted to do myself. So I just thought I'd drop this in here. And this is something that Ken did back, I think, in '01, I believe. Um, but today, what we really are going to do is we're going to look more at these exotic vacuum objects, which were coined by Ken Shoulders. Zero point energy is actually coined by Ken Shoulders as well. And we're going to have Brandon read through this one paper. It's going to describe the atomic structures and how they relate to exotic vacuum objects. And then we can have some good discussion after that. So, Brandon, I'll let you do your thing.
Okay, thank you, Eddie. Okay, so I'll start with this paper here. A pair of atoms with the same structure but with oppositely rotating protons. Pavel Osmira. Abstract. Using the ring model of atoms and molecules was revealed that there must be two types, type A and type B, of atoms that differ in the direction of rotation of individual rings. For type B, all rings rotate opposite to the directions of rotation for type A, but have the same structure. The rotations of protons and neutrons in atoms are given by a system that resembles a cogwheel in a gearbox. Both types A and B have the same structure. Solution to this problem was found in the design of titanium dioxide, or
Yeah.
TiO2 model, which has a total of 22 protons, 22 electrons, and 26 neutrons in titanium atom Ti. This also applies to the oxygen molecule. Both oxygen atoms have the same structure, but the individual protons rotate in opposite directions in both atoms. Magnetic lines of force with opposite orientations are then created in the proton axis. Only such oxygen atoms can combine to form an oxygen molecule. Magnetic lines of force emerge from one proton of the first oxygen atom and can thus enter the proton of the second oxygen atom. Each oxygen has 8 protons, 8 electrons, and 8 neutrons. Keywords here are ring model, direction of rotation of proton, neutron and electron, directions of magnetic moments, photocatalytic cleaner with titanium dioxide, graphene, photocatalysis, titanium dioxide, and ultraviolet light. Introduction. Currently, children in our schools are taught that the nucleus of atoms consists of balls of protons and neutrons. Electrons orbit around such a nucleus. This model has inspired by the planet. This model was inspired by the planetary system, where individual planets, including the Earth, orbit the Sun. This Bohr model cannot explain, for example, the hydrogen molecule, which consists of two hydrogen atoms. This model needs to be modified. Electrons, protons are not balls, but rings with fractal structure. But in the hydrogen atom, the electron is attracted by an electric force and repelled by a magnetic force. In the Bohr atom, the repulsive force is created by a centrifugal force. What is interesting about both models of hydrogen atoms is the distances between the proton and the electron are the same in both models. There we see some images: sphere,
Yeah.
ring structure, torus, the classical and the new, structure of atomic nuclei, and then the structure of atomic nuclei in the new way of looking at it.
Hmm.
Classical shows planetary system. In the new, it shows levitating system. String theory, 10 dimensions, no self-organization in the classical, and in the new, dark energy and dark matter, open, radiation energy, closed, particle matter, fractal ring, vortex theory, 4 dimensions, self-organization.
So one thing I just wanted to point out here is that, yeah, when you look at the open system, when the rings are all open, you essentially have energy or radiation. And when you close them, that's when you have matter or a particle. So it's kind of a little bit important there. Um, yeah, carry on, Brendan. Thank you.
Okay.
I'd like to get that and make a big poster of it, please, if I get it.
Yeah, yeah, I'll make sure that all this is dropped in our group also. Yeah.
The classical approach in particle physics is based on the fact that the electron has some parameters like charge, mass, etc., but does not have a structure. The electron is calculated as a point particle having magnetic properties. Combining knowledge of physical chemistry, evolutionary optimization, 3D graphics, programming in Python, and mathematics make it possible to create programs for designing new nanostructure models. The first testing proposal for the nanostructure prediction program is limited to carbon structures. On figure 1 are classical and new models of nature. So that was that figure there.
Yep.
VFRT, vortex fractal ring theory, uses the electron, proton, and neutron as the particle with a toroidal ring shape, which is formed by fractal substructures. Connected to each other by vortex electromagnetic fields. The atomic nucleus can be built from ring protons and neutrons. Combining knowledge of atomic nucleus structures and evolutionary optimization makes it possible to create programs for designing new nanostructure models. The first testing proposal for the nanostructure prediction program was limited to carbon structures. The aim was to verify whether the proposed program is capable of generating known carbon nanostructures, such as graphene. The following versions of the program will no longer have this limitation. So we see figure 2, levitating ring electron in the hydrogen atom. Figure 3, basic substructures of the atomic nucleus. The left structure is a helium nucleus, alpha particle.
Is that
Right structure.
is that model the ring model versus the? You scroll up just a hair, scroll up just a little bit. That graph is that force versus diameter. Is that what I'm seeing on the axes?
Force that
When you
could be
because obviously the ring model is the correct model,
Yeah.
but I'm saying that force is kind of like the Bloch wall. At all things, it's that 0 point and how it drops off to zero right there. That's kind of I believe that's what it's set. It's shown at the graph F versus D. I believe it's force and diameter or
Hmm.
And it's basically showing that diameter between the electron and the proton.
Could be electric
Which is
force, magnetic force, or electric force.
Hmm. I think it's going to explain it more as we move along here.
The left substructure is a helium nucleus alpha particle, that one there. The right structure is not used in the periodic table of elements. That's that one there.
Which is interesting.
Three substructures in the middle are key. Here we see some periodic elements
Yep.
in
They start.
terms of the new type of ring structure.
Yep.
Periodic table of elements. Figure 5. Hydrogen molecule with covalent bond. Topological structure. Rings are not in right scale. Figure 6. Vortex structures. Structure of light as a ring particle or a wave energy structure. Mathematical description. Electron radius RE and spin S. ME is the mass of the electron. VE is the circumference. How do you say that?
circumferential.
Yep.
Circumferential velocity of the electron ring, and lambda is the wavelength, the Broglie equation. Figure 7, an electron. That one there. Okay, here's some more mathematics. Spin SZ of the electron and magnetic moment MZ. 2, a pair of atoms with the same structure. Figure 8, oxygen molecule with oppositely rotating protons, type A and type B. Both oxygen atoms in figure 8 have the same structure. Those two oxygen atoms to make an oxygen molecule.
Hmm.
Both oxygen atoms in figure 8 have the same structure. The direction of rotation of the rings differs. Bonding, it is important to have both types because a magnetic field leaves one atom and enters the other. Figure 9, titanium dioxide model with oppositely rotating protons, type A and type B. The rotations of protons and neutrons in atoms are given by a system that resembles a cogwheel in gearbox. Both type A and type B have the same structure. The titanium atom Ti model has a total of 22 protons, 22 electrons, and 26 neutrons. Each oxygen atom has 8 protons, 8 electrons, and 8 neutrons. The titanium dioxide model therefore consists of 118 rings, protons, neutrons, and electrons. Two types of electrons are distinguished in the model. Valence electrons are colored light blue, and inner electrons are colored dark blue. The direction of rotation of the proton determines the direction of the magnetic moment that exits the atom. For an external view of the proton, it has for clockwise rotation of the proton. The proton has a magnetic moment that exits the proton, yellow arrow. For counterclockwise rotation of the proton has a magnetic moment that enters the proton, green arrow. Obviously, this is maybe color, maybe in
Yeah, I have a color version of it actually.
For example, in the case of the oxygen molecule O2, oxygen atoms of type A and type B are joined. The magnetic moments of the binding of two protons must follow the same direction. Only the magnetic moment with the yellow arrow can be combined with the magnetic moment with the green arrow, figure 9. The air cleaner uses familiar principles, but in an unconventional, original way. The surface with titanium dioxide is activated by ultraviolet light, a wavelength of 365 nanometers, band A with the maximum photocatalysis efficiency. The airflow is done by two fans that have an adjustable speed. Photocatalysis breaks down viruses, including coronavirus and all its current and future mutations, into harmless atoms and molecules. The activated surface of titanium dioxide removes binding electrons from the structures. Ultraviolet light with a wavelength of about 365 nanometers and A is used to activate the photocatalytic surface, in contrast to hard radiation with a wavelength of about 200 nanometers, band C. Hard radiation kills living structures, but does not break down into simpler structures. We use ultraviolet light generated by ultraviolet light. The advantage of ultraviolet LEDs, that might be a typographical error. Might be LEDs there, but anyway. The advantage of ultraviolet light LEDs, light emitting diodes, is that a low and safe DC direct current supply voltage of 12 to 24 volts can be used. We can only hope that this principle will help slow down or stop the spread of viral diseases. Photocatalysis also decomposes harmful bacteria, fungi, unpleasant odors, cigarette smoke, and chimney smoke, and harmful gases from cars and motorcycles. Conclusion. All atoms exist in two types, type A and B. They have the same structure but have opposite magnetic moments. All models of topographical structures, the fractal model of the proton, neutron, and electron, allows us to explain what dark matter and dark energy could be. Small fractal substructures can be part of dark matter and energy. If they form closed structures, rings, they are matter. If they form open chains, they are energy. Unfortunately, these small fractal substructures cannot be observed with light. Dark matter, see figure 1D new, manifests itself, for example, in the equal rotation rate of the inner and outer parts of galaxies. Giving some references here.
Yeah, I think that bottom reference, number 5, is kind of the important one. I think that was his original paper, which I haven't got dug up yet, but I'm going to have a look at. And yeah, so this definitely does apply to exotic vacuum objects, although he doesn't talk about them in that term. And then after the paper here, now we just have a whole bunch more slides where we're talking about these exotic vacuum objects. And again, from Bob Greener's work in February of 2020, you have these rings within rings, wheels within wheels, essentially, this structure. which is shown, in Pavel's work as well here too. You can just keep going through them, Brandon. We'll just talk about them as we move along. You guys can jump in at any moment here too. Um, Here we have the D4D structure. The first D is the main big ring, and the 4D are the little smaller rings that rotate at essentially 90 degrees to it, or orthogonally to it. The cone shows goes up through the middle there, basically shows the the focus point, or the point where it's most important. Yeah. So that part that points to the middle, yeah, that part right in there shows the important part. Some of the stuff that we've already talked about on some of the other Ken Shoulders ones that we've done. I just wanted to bring up the visuals for you guys, just so you can kind of have them to look at again. You can carry on if you want, Brandon. Um, and now this one we should talk about a bit, because this is really the sacred cow, if you so to speak, in physics, if you want to talk about it in those terms, is the monopole. This is something that's not supposed to exist, but clearly it does, and comes out of these models with Ken Shoulders and these ring vortex models, essentially. So you have spin one way, spin the other way, causing this monopole location, which was pointed to there. Yeah. Here we just have a picture that we first showed. This was the actual, what inspired me to start doing all of these Ken Shoulders things with you guys. It was this picture. When I saw it, when I had all the 600 pages printed off that Chris gave me on Ken Shoulders' work, this page fell out onto the floor. And when I saw that, I realized that it looked exactly like the structures that I'd seen from Bob Greenyer and a whole bunch of other people's work.
Is it a simulation or a photograph?
I believe that this is a computer simulation. Yeah, I believe I do have photographs of EVO structures that we have shown in some of the other Ken Shoulders ones, but I believe that that's a computer simulation. Yeah, and that is when we did go
You're
through
all
that.
aware that, simple life forms, bacteria especially, plasmid DNA, little rings of DNA, not these long chains. And like that's the basis of life. I mean, the very simple life, exactly what it is. And you just take out the O, DNA plasmids. I used to grow them in a lab when I was,
Yeah,
college.
yeah,
But I mean, it's like, but eventually the rings become, really they become thought forms and everything else.
yeah,
I mean, that's what you are. But I mean, when these things, when you start with everything's time and motion, but you have to create repeating patterns, things that last through time. Now, some of these DNAs, I mean, you can preserve them for forever. And I mean, really, that's no different than when you start to get into computer programming, things like that.
yeah,
But everything's we exist in a world of motion. I mean, everything can be
yeah,
reduced to motion.
yeah. It's about spin. Everything's about spin and motion. You're absolutely right. I think the
And
next
at
one
the
we'll
center point, that was when you were pointing out in the picture. The center point is always the power point.
yeah, exactly. Yep, yep,
Like, and
yep,
you can induce a center point by creating spin and then get power from that. I mean, that's kind of what all these technologies are doing.
yep. So I think Brendan, the next few ones there were just color pictures of the different structures. You can see neon and helium and all the others. It is kind of noteworthy to see how there are some structures that look quite the same, and I think he's kind of got them all put in these different categories, because if you go down and look at these structures, they're all quite similar in each line essentially, and that's kind of interesting. AG not gold,
So AU is
or
gold, AG is silver.
silver? There's silver. Um, yeah, it's
Nickel,
pretty interesting work.
rubidium, I think that's rubidium.
Yeah, there's cobalt.
iron, cobalt, nickel, copper,
copper.
zinc.
Yeah. And see how all those structures are kind of the same? Those ones that you just went through, iron, cobalt, nickel,
Copper,
copper, zinc.
iron,
Is that Mn? Is that molybdenum? No. What's Mn?
Manganese, yeah.
no, it's not magnesium.
Manganese, yeah.
Magnesium?
No,
No,
magnesium
manganese.
Mg.
It's manganese.
Manganese. Ah, there you go. Thanks. Yeah, manganese.
Germanium, I think that is. I'm not sure. I can't remember what that one is. But
Yeah, I don't remember them all either.
these are the
But
noble
anyway,
gases
you know
here.
what's neat though? So one of the things that's out there for free, you can go download it for free. The Millsian. So Randy Mills, I brought him up so many different times. Again, his model, he's so brilliant, yet he missed the main thing. It's like an Einstein thrown away the ether. But I'd say Randy Mills is probably the most brilliant physicist, aside from the most boneheaded error with not understanding the ether aspect and some of this aspect. But he's on his Millsian software. I'm not real great at using it, but what it shows is you can build out large volumes of molecules and show their interaction. These standalone are neat, but when he starts showing the structure of like solid neon and solid because basically everything, there's all speak volumes about what the inert that gases actually are.
Mm-hmm.
But
Here's
basically, when you start with the super material properties of the future, when you start having self-powered devices and also using quite odd chemistries, things that we don't even have now. I mean, it's quite a nice place to live in. Let me tell you.
Here's this is pretty interesting here because this shows the hydrogen molecule, but with the spin and counterspin setup going on essentially, right?
Hydrogen molecule with covalent bond topographical structure. Rings are not in right scale. Spin is like the arrows.
Yeah, you can see the direction that everything's spinning. The magnetic field lines, the electric field lines.
Proton, electron, proton.
Yeah, proton, electrons, yeah. So this is where he's talking about type A and type B and how the only difference between type A and type B are this counter rotation. So essentially with the counter rotation at the null point, I think is where the magic happens. That's kind of what we're looking at. And I think if you keep going, Brendan, we're gonna go into there's a color version of this that just shows it a little bit better, the structures. This stuff we'll post so that it's up for people to have a look at. The bottom one there is probably the most remarkable, where he's talking about how if it's open, it's energy, and if it's closed, it's matter. Very, very interesting work on his part, definitely. And I think if you keep going through, this is really interesting, and you guys might want to jump in on this. Chip, see what you think about this. This is showing different interactions, essentially, with the different
Toroidal
modes.
Mode, magnetic dipolar mode, electric dipolar mode, toroidal mode, optical excitation, and field illustrations.
With the energies associated with it.
Yeah.
2.5 electron volts, yeah, and so frequencies embedded in the energy distribution, obviously. I have never seen anything like this. This is phenomenal.
Yeah, I know, right? That's
God.
That's what I thought too. That's why I wanted you guys to show it to
Freddie,
you.
Man, you see a six-face reality right now.
Right? Yeah, this guy's on it. I'm going to try and contact Pavel if he's still around. This paper was from 2011, I think, so it's quite old.
Is he Russian again? Sounds like he's Russian.
I found him through through those channels. I'm part Ukrainian and know Russian quite well. I can speak about half of it, or understand half of it. Can't speak much of it anymore. I haven't done it in a long time. But yeah, so this is really phenomenal work here. Yeah, very cool. I think there's another one that's really interesting. Well, okay, so this is something that I came up with from, again, Bob Greener's work. It just shows uh, things a little bit better, um, maybe a little bit more clearly in the focal points, how each has got its own essential focal point and how they interact.
Look at the subfoci on the ring. That is so cool.
The which?
The subfoci on the ring there.
Yep. Yeah, very. I find these visuals help a lot. Give a guy a better understanding of what's going on. Now, this one I want you guys to chime in on too, because this has got some wild stuff on it as well.
Modality transduction effects. Photonic, mechanical, electromagnetic.
Piezo channels. There we go to the biophysics and bioelectric fields. Calcium.
Yeah.
Plasticity. Apoptosis.
This is all really, this is beautiful, by the way. I mean, this is, I think, this is like almost like a culmination type thing. I've been searching for answers my whole life, and kind of all the little building blocks kind of leading up to this certain place. And when you see this, like, oh, this all makes sense. What a beautiful creation.
I know when I saw it, Michael, when I saw it, I thought we have to do this. Have to show you guys what's going on here. Yeah. And look at the microtubules.
One of the neat things, though, I like my equations, and we can talk this a whole different episode, but you can't see this. I don't think you can. I like equations. If you look at them, you can see like divine proportion and anyway, there's all kinds of things you can say about correct equations. But there's one equation that defines the elementary charge. Basically, if you want to break reality into its very basic concepts and everything in this world of charge, which charges how you move things, how we do anything, how you power the world. So basically, the elementary charge, and I can speak Steinmetz work. I mean, this stuff will blow your mind, but this is called Elementary Lectures on Elementary Charges, Waves, and Impulses, and Other Transients. And everything, he kind of like a Ken Shoulders, Steinmetz, and some of these just absolute brilliant minds. They're always worried about like the in-between, and if you keep looking small enough places, you'll find.
Yeah, well, that's Paul Laviolette. He that's where subquantum kinetics came from, essentially, right? Paul was definitely a genius. There's no question. But so this is really cool. I don't know if there's another one after this or if this was the last one, you guys. That was the last one, yeah.
Cryptochrome. Look at the one on the bottom there. He had a cryptochrome on the bottom.
Yeah, let's have a look at the bottom one there again.
Yeah, along exactly. With the there. Cryptochrome, my God, that frequency and light color comes out of the vacuum field as well. It's emergent, self-emergent, and so cryptochrome is playing a part in the biophysics here. Got
the microtubules.
Yeah, the helicity with the cryptochrome, and yet it's folded in distinct trapezoidal geometries there. He's spitballing some things, just throwing it against the wall here, but he's showing thoughts that he thinks are interrelated. I don't know if he develops any real hard math or anything for them, but in his instinct here is just throwing things that seem to be interrelated for him, and it resonates. It's very interesting. Induction.
Yeah, it is, right? Induction, yeah, exactly. Yeah. I was looking at that, right?
Yeah, the cryptochrome structure, the helicity alone will either cancel or enhance induction, so you've got magnification of the electrical field within the M tubes.
Beautiful. Caused by phase conjugation?
Yeah. Right? It's like a little damn rail gun.
Yeah. Exactly. Yeah, it all kind of interrelates. Yeah. So a fantastic work in paper, definitely. When I saw it, I thought, yeah, we have a closer look at this because it all does definitely relate. The structures are all the same. Yeah,
Well, he's got the EMF fields with photonic. He's got acoustics with mechanical. He's got the electrical field. He's got the monopolar aspects to this with induction and M2s. Wow, he's covering the whole gamut.
yeah,
I don't understand the plasticity thing, but
yeah.
differentiation, migration, proliferation,
Plasticity.
apoptosis. Yeah, apoptosis is cellular death, programmed cellular death. Polarities. Wow, threw all the spaghetti on the wall.
Yeah, yeah. It's pretty cool work. So it seems to me like he talks about this type A and type B, which are counter-rotating these models. And whenever we have this counter-rotation at the null point is where we have the magic or the focal point. And I think that's something that we have to think about. That's something that I've been thinking a lot about in the last, 3 or 4 weeks that I've been looking at these papers, essentially.
That counter rotation should be truly three-dimensional as well, much like a gyro, which
Yep.
I have one of those. It's a
Yep.
quantum device,
And it'll have wobble, it'll have precession too, right? It has to have precession. And if you phase lock the precession, that's how you can control these things, just like an MRI machine works. It's exactly how an MRI machine works, right?
that wobbles completely, continuously producing potentials.
Yeah, exactly. And the wobble is like probably one of the most important things if you think about it. If the wobble wasn't there, it wouldn't work.
Absolutely, yeah. And I've seen some interesting podcasts on the wobble. Very specifically, people are recognizing how important that is.
Yep, yep, definitely.
You wouldn't think it would contribute to resonance, but it's exactly what it does. It's so counterintuitive, but
Yeah, yeah, it's pretty cool stuff. So, do you guys have any other comments on the papers or anything you want to say before we stop the recording?
yeah, let's post these bad boys. I need to spend several hours and go through them.
Yeah, yeah, we'll put them up in the Signal group, and yeah, definitely.
Okay,
Yeah, there's
so
some.
I'll just say, well, thank you very much, everyone, for watching.
Yeah,
Hope you have a wonderful rest of the day.
and thank you, Brendan, for talking today.
Cheers.